So the topic that I'll be covering today is using CCLAS to standardise analysis across multiple laboratories. So my topic will cover a bit of a history of Iluka and the laboratories that we run, our CCLAS installation prior to an upgrade in 2016, what our CCLAS system became, and then how we were able to standardise our analysis. So Iluka is a global mineral sands producer and now moving into rare earths. The primary operating mines and process facilities are in Australia. We also have marketing facilities worldwide. Sierra Leone was purchased by Iluka, that has just been divested. So our mineral sands the applications that they go into cover titanium dioxide, zircon and ilmenite. So our zircon that we produce can be used in ceramics or foundry sand applications used such as investment castings. Titanium dioxide that we produce goes into a multitude of different areas, primarily pigments for paints and into the welding rod market. And with Iluka's move into rare earths, with our production facility at Eneabba, will be primarily producing rare earths to go into wind turbines and electric vehicles. The operating facilities that Iluka has, so we have our Cataby Southwest, business unit. So we have our Cataby mine producing a heavy mineral concentrate, and in Capel we have our synthetic rutile kiln that produces a high-grade titanium dioxide product. In JA Midwest we have our Jacinth Ambrosia zircon mine and our Midwest mineral separations facility. Out of that we produce zircon, rutile and ilmenite. As I've said, at Eneabba in 2020 we've just commissioned a monazite processing facility. In 2022, or just recently, that has been upgraded to a concentrator and flotation circuit that can produce a 90% monazite concentrate, and the Iluka is now progressing through to a full rare earth refinery at Eneabba, and our Sierra Leone rutile facility, which is now its own standalone company. Just a bit about our laboratories. So in the southwest, our southwest laboratory supports the operation of the synthetic rutile kiln. They use a multitude of different techniques, X-ray analysis, so XRF, XRD, and wet chemistry. They do a lot of testing for activated carbon, support our metallurgical testing facility, and also do mineral composition analysis of our exploration samples. So with our drill samples, they produce composites, which can then allow the geologists to understand the mineral assemblages of what's in those samples. The Midwest laboratory is slightly different. So we support the Narngulu mineral separations plant. Primarily, we perform all of our exploration drill testing for slimes and heavy mineral content. So that is primarily just within Australia. We have our zircon testing facility. So with our zircon that gets sold into the ceramics market, one of our important features of our zircon is its colour as an opacifier. So we actually do glaze testing. So we actually produce a zircon glaze and apply it to a tile, measure the colour of that tile and compare it to our reference standard. And we also, in the Midwest, undertake quality predictions of products that could be produced from our exploration drill samples. The the Murray Basin laboratory, which currently isn't operating, that was very similar to the Midwest lab. The only really difference is they primarily focused on the deposits around that Victorian area. So just to go into a bit about what our CCLAS structure looked like prior to 2016. So at each of the laboratories we had an individual instance of CCLAS that produced or sent data to our history database, and then our three primary data importing systems, production accounting, environmental, and our geology systems pulled data from CCLAS. There was some problems with that, so the CCLAS instances had been in use probably from the mid to early 2000s. So being isolated, the schemes that had been produced were all, I guess, slightly similar, but could be unique. There wasn't much sharing between laboratories, so we would generally create new schemes as we needed to. Sorry, I'm just need to see what. So the outcomes for that was that there was complexity all throughout. So production accounting systems needed multiple data pickups to accommodate the three labs. It could be difficult to compare results between laboratories because the assays that were reported might be slightly different in the techniques. And there was one instance where there was a fairly sizable financial impact where some results were generated and there was a bit of misunderstanding or poor interpretation of the actual zircon grade in the deposit, and as a result some poor financial metrics were applied to that deposit. This is one specific example of of a test that we did or we do, where there was slightly different calculations used from the three different laboratories. So this is our heavy mineral separation test, where we put a mineral sand sample into an open funnel containing LST liquid. The heavy mineral sinks to the bottom. The LST has a density of 2.85 and quartz floats on top. And we collect the heavy mineral from the separation funnels. So you can see that the three calculations were there. The Murray Basin and the Southwest laboratories could potentially produce the same result, although the Southwest used separate or could use different sizes, and the Midwest calculation was completely different. So that certainly caused a bit of confusion when results were being generated from different laboratories. What I'm going to cover now is just what our system was. So we worked with Datamine in 2016 to centralise our CCLAS system. So we now have one CCLAS server that all of the laboratories share. We have one history database, and that now all of our data importing systems picks data up from the one system instead of three. The beauty of this structure that we built is that it is easily expandable. So I've been working with Dave and Roman, and we've just implemented an Eniaba laboratory within our system now, which was fairly straightforward in how we did that. The way that we structured it, there's common themes that run through the lab, so we all share our schemes, our pricing, rounding tables and quality control standards. We use lab codes to, I guess, filter and provide our custom experience for each of the labs, so our own product codes and our own file structures within things like data entry and jobs. So it feels like we're running our own CCLAS system, but we share quite a fair bit. And then we have our scripts that run behind. Again, some are common, so we denote them as global scripts, and then others are local. And you can just see just an example of our folder structures of our Midwest and Southwest labs. So in 2016, when we looked to standardise our laboratories, we obviously had to review what we had in existence. So between our 3 laboratories, Southwest, Midwest and Murray Basin, we had a combined total of 214 schemes and over 4,000 unique analytes. So with the help of Datamine, we went through a process to filter down what we actually wanted to include into the new centralised CCLAS. So we essentially followed this process flow where we looked whether the scheme was in use, and if it was a sort of redundant scheme that wasn't really needed anymore, we didn't include it. The schemes that were unique, so the Southwest, for example, might have had their scheme that they use for their mineral assemblage determinations is unique to their lab, so that just got implemented as is. And then for schemes that were common, so for example XRF, we reviewed the scheme itself, we reviewed the analytes that were included, we agreed between the 3 laboratory managers of what the final scheme would look like, and then once we had that sign off, we implemented that. So I've just got a few examples. I actually counted our sizing schemes in our 3 separate CCLASs, totaled 30. And when I looked through what they were, a lot of them were built for a specific purpose. So we had sizing schemes for ilmenite products and zircon products. And the way that we actually looked at how we could improve this was to, I guess, simplify everything. So we use nested if statements, I guess, to allow flexibility within our sizing schemes. So instead of having separate schemes, we could then customise each scheme in a job template. So in the end, we only ended up with 7 sizing schemes in total. And another benefit of this process was that we were able to standardise our analyte names. So in our old system, we had, I think, over 5 different variations of reporting minus 75 micron, which made our production accounting systems complicated because depending which lab you came from, it may have been called something slightly different. Now we only have 1. Our heavy mineral scheme was similar, so we had well over 40 unique analytes when we combined our 3 schemes in total. What we actually had to do in this instance was actually define what was the output of this scheme, so or define. So what we ended up working out was that our heavy mineral result needed to be reported on the sample as received. So when we fine-tuned the scheme itself, we brought the number of analytes down to 13, and then we standardised the reporting method. So when we report heavy mineral, for example, the result there is 91%, so that was 91% heavy mineral as the sample received in the lab. And we also report a sizing result alongside that. So that's used by potentially production to work out what the grade of heavy mineral might be of the sand in the plant. This is I guess a benefit that we didn't actually foresee when we built our CCLAS system. So in 2018, we kicked off our Cataby mine just north of Perth. So it produces a heavy mineral concentrate and then undergoes magnetic separation on site. The magnetic fraction of that, which is primarily ilmenite, heads down south for processing at North Capel before being put through the kiln. And the non-magnetics, which is a combination of rutile and zircon, heads to Narngulu for processing, where we produce our zircon and rutile final products. When the business kicked that off, it was decided to use the Southwest methodology for determining mineral assemblage. Because of our centralised system in Narngulu, we didn't use that at the time, but we were able to use the scripts that were in the Southwest and the scheme that had been produced. And within a week, we had everything set up to report in the same manner as the Southwest. So results that now go to our production accounting system from the Narngulu and Capel laboratories use the same methodology and same testing methods. So having this centralised structure made this process very straightforward to implement, which was very good. So how we achieved our successful implementation came down to a number of factors. So I guess one was the alignment of the three laboratory managers to have a common goal on what we wanted to achieve and how we would achieve it. A lot of it, there was a lot of common schemes, so we needed to understand exactly what we were reporting and what our test methods were, so that if there was something unique to our particular test that might be slightly different to the other laboratories, that we allowed that customisation in the schemes as we had them built. The Datamine provided a lot of support and a lot of guidance and I guess ideas. So there was a lot of, particularly the sizing scheme, there were things that we probably hadn't considered before, or ways in which things had been set up possibly in other laboratories. We were able to utilise that information from Datamine and support from our IT. So with a lot of the new analytes that we created, obviously they had to change in our production accounting system. So it was essentially when we upgraded or standardised our CCLAS, we also copied that standardisation across to our production accounting systems. And so what did it achieve? So I didn't actually count the number of schemes that we've got, but we've probably got less than 100 now. So the complexity of our CCLAS system reduced significantly. It made it less ambiguous with the data that we were reporting to production accounting, and standardised a lot of our analysis between our laboratories. So the same results from different laboratories meaning the same thing. And it also improved our collaboration. So I think our laboratories work a lot closer now than what they historically did. So yeah, I think that's it.
Thanks, Shaun. Any questions for Shaun?
So, question on the centralised
Mm-hmm. So just a question from the floor about the centralised structure of CCLAS at Iluka.
Yeah, so the structure that we went with, we operate CCLAS via a remote desktop, and we also, it's a dual service setup, so we've got shared loading so that we don't, I guess we try and split the loading over 2 servers from the different labs. We've probably only had a handful of outages in that time where we've lost, I guess, network connection to Perth. So we don't really have any redundancy, but yeah, there hasn't really been too many outages that sort of causes any grief. Yeah, we did a lot of speed testing during the sort of setup, so that particularly operating CCLAS on our east coast from our servers in Perth, yeah, they certainly were adequate in their speed.
Yeah, I think that from that project, Shaun, I think the biggest challenges we found when you have remote service is the transportation of data from balance. We found that was a little bit laggy, so I think we put in some solutions to save that data to, instead of using a COM port, because there was some lag there, we saved that data to a file and just processed it in a different way. But I think you guys were, like, you know, in terms of how you set the systems up and you know, the ability to be able to run CCLAS in the same way in Murray Basin as you ran it up, you know, your mine, it was, you know, so quite a testament to, I'm trying to remember the IT guy's name, Andre, yeah, so it's quite a testament to him. And as I think you pointed out, Shaun, you know, when you you know, run a CCLAS or a LIMS project, you know, laboratory manager is important. We play a part in that. But, you know, IT having, you know, support from IT and have a lot of knowledge there that everyone works together, that's when they'll always, you know, it'll be a successful project. So, sorry, Rob, go ahead. Yeah, the question was if you use cloud storage for your data.
No.
I don't think you do. No. I'll talk a little bit about cloud stuff in my presentation, Rob. Yeah, so that's stuff that we're starting to see a little bit more and more of. Some businesses are pushing towards that. Some mining companies are, you know, yeah, push against it, but there's different. It's going to change, I think, over time. We're just starting to see that evolution now, I think. Yeah. David?
How do you deal with the transition from the old system to the new system and that data? Because obviously you've got, you know, your initial data of this is the sample we have now, and
yeah,
how did you get that to marry?
Sorry, Shaun. So the question was, how did they transition from using the older sort of CCLAS system with the differing data names to the new CCLAS system?
Yeah, so we did stage rollouts. So the Southwest Lab was the first cab off the rank. It was also slightly complicated with not only new CCLAS, we also had new PCs as well. So for a period of, when we did the initial rollout, there was complicating factors. So I think for a period of time, they actually duplicated the results in the new system and the old system. And once a number of sort of local IT issues were resolved with permissions and the work, that there was enough confidence to run purely off the new system. And then I think there was a 3-week gap between the next installation in the Murray Basin, and I think that progressed within a week. And then by the time the Midwest laboratory came on, we did that in 3 hours.
Yeah, you had the easiest one.
Yeah.
I don't know if you planned it that way, mate, but yeah, well done. Anyone else? All right, well, please thank Shaun for his presentation.